Okay, so starting from this video, we're gonna do something cool. So if you go to the Aptos documentation, they have a guide where you build a full stack application, starting with writing your move module, all the way to building your front end, integrating them together, the whole shebang. So until now, we went through various beginner guides on the documentation, building your first move module, sending your first transaction, creating your first fungible asset on Aptos. But those are all components, right? Well, starting today, we're gonna go through this longer beginner guide where by the end of it, you're gonna have a fully working application on the Aptos blockchain. That means by the end of this video, you will have learned everything that you need to know as a full stack developer to build your application on the Aptos blockchain. This is my first time going through this end-to-end guide as well, so I'm super excited for this one, and hopefully by the end of this mini series, I have a working application on the Aptos blockchain. So get your computers ready and let's build this application. Okay, so like I said, today we're gonna go through the end-to-end beginner guide on the aptos.dev documentation. So head over to aptos.dev and then go to the guide section, click on beginner. And if you see, there's a subsection called build end-to-end DApp. So it's divided into 5 sections. So it's a monster guide. That's why I'm going to be dividing it into multiple videos. But hey, by the end of a couple of videos, we'll have a working DApp on Aptos. So let's do this. All right, let's start with the overview. Build an end-to-end DApp on Aptos. A common way to learn a new framework or programming language is to build a simple to-do list. The traditional way of learning language. In this tutorial, we'll learn how to build an end-to-end to-do list DApp, starting from the smart contract side through the front-end side, and finally use of a wallet to interact with the two. Beautiful. So that's really, the components, like the minimum component that you need to build a DApp. A front-end, a smart contract, and probably an SDK to kind of interact between those two, and a wallet to sign transactions and do on-chain activity. All right, so there's a completed code, source code here. I'm not gonna look at that right now. Let's just continue on. All right, so the chapters. After meeting the prerequisites and getting set up as described below, you will follow this tutorial in this order. Creating a smart contract, setting up a front end, fetch data from chain, submit data to chain, and handle tasks. Cool. Okay, let's go through it. Prerequisites, you must have Node and NPM installed. So I have those installed on my computer, but if you don't have it, you can click on this link, get yourself Node.js and NPM installed on your computer, because we're going to be needing that to do JavaScript stuff later on for our front end. Okay, so although we will explain some React decisions, we're not going to do a deep dive into how React works. Yeah, so obviously, we're not going to be teaching React to you guys. We're mostly going to be focusing on how to implement Aptos-related components here. So, if you want to become a more skilled front-end developer, there are probably a lot of amazing tutorials on React on YouTube and, online resources. So check those out if you want to become better at React. Setup. In this section, we'll create a My First DApp directory to hold our project files, both client-side code, React-based, and the move code. For that, we'll be using Create Aptos DApp to create the project. Cool. So if this is the first time you're seeing Create Aptos DApp, this is this amazing tool that the Aptos team has created where you run this simple terminal command and it bootstraps an entire Aptos DApp for you. So you don't need to start from blank slate. It has like multiple templates, like full stack templates with a working front end and a fully fleshed out move modules for various applications. So if you want to start with there and just like customize, you can do that. But they also have boilerplate template where it's very bare bone and you can just start from scratch. But yet it has all of the necessary components like the folder structures and the configurations for your project, all that stuff. So feel free to like kind of go through this page here to learn more about Create Aptos DApp, but that's kind of what it is on a high level. Okay, so open a terminal and navigate to the desired directory for the project, for example, desktop directory, and run nps create aptos DApp latest to create the project. All right, so let me copy that command, go to my terminal, and then go to a directory that you're going to create the project in. So I'm going to paste that in my Chris Learning Aptos video series directory and run that command. Okay, does it tell me what to do? Follow the instructions to create the project. Okay. Choose a name for the project. My first step, choose the Fullstack project option, choose the boilerplate template option. For simplicity, choose not to use Surf. Okay, don't use Surf. Choose the Vite app framework option. Choose the DevNet network option. Okay, probably not going to remember that, so we'll go back and forth. I'm going to just use the same naming that this guide has just to reduce complexity. Okay, so name of my project, my first app. Cool. It's set to choose Fullstack, boilerplate. Don't use Surf for simplicity. Client side, so Vite app, and then DevNet. Cool. Then ask me for an API key. This tool will create the project. Okay, so this guide doesn't talk about API keys, but it's highly recommended to use. So for those of you who don't know, the Aptos Labs team has created this amazing tool called Geomi. And it used to be called Aptos Build, but now it's called Geomi. And you can go there and create your API key to get higher rate limits for your transactions and like TypeScript calling and all that stuff. You can go to Geomi and get yourself an API key that gives you higher rate limit so that when you're building, you don't run into that rate limit too often and kind of help with your development process. Also later on when you launch your application and it requires a lot of indexing, this is a really great way to do that, and it has some amazing features there like gas stations and stuff. So not going to be going over that for this video, I believe, but definitely check them out if you're interested. So for this one, I'm going to say no. Okay, next up, it's asking me, do you want to make any changes to your selections? Default is no. Okay, then I will say no. Cool. Then it's scaffolding my project. Beautiful. It's installing dependencies. Oh, in the meantime, it's giving you this link to look at the boilerplate template docs. So, yeah, you know what? Why not? Let me copy that. Let's see. Okay, so it's taking me to the Aptos Learn page and to this boilerplate page. Cool. So the boilerplate template provides a starter DApp with all necessary DApp infrastructure and a simple wallet info implementation. Very cool. So folder structure has the front end and contracts folder. Nice. So it gives you information about what the boilerplate template holds. Very nice. I'm too lazy to read it now, so feel free to read it if you want, but I'm going to continue on. Okay, so install the dependencies, installing Aptos CLI. Okay, so it installs Aptos CLI for you even. Cool. So I guess if you're completely new to Aptos, you don't even need to install your Aptos CLI. Just running this Create Aptos DApp function will install it for you. Very cool. Okay, next steps. Run cd my first app and open in your favorite IDE and follow the README file. Okay, simple enough. I will cd into my first app. Cool. And open it up in my favorite IDE, which is VS Code. Yes, I trust the author. All right. Okay, I opened it in my IDE. Let's go back to the guide. Okay, now let's create a smart contract. Beautiful. What does this link do? It takes me to the next guide. Okay, cool. So we're in the next guide now, and this one is to create the smart contract, the to-do list smart contract. This is the first chapter of the tutorial on building an end-to-end DApp on Aptos. If you haven't done it, review that introduction and ensure your environment meets the prerequisite listed there. Okay, I just did that. Now that you're all set up, let's explore the contract directory. All right. Okay, so we have a bunch of stuff here, but we have this contract folder. So let's go to that one. And it holds the sources folder, the test folder, and the move.toml file. If you've been following along the Chris Learning Aptos series, you would have already seen this and why these folders and files are necessary. But this guide also explains it. Okay, what is a move.toml file? A move.toml file is a manifest file that contains metadata such as name, version, and dependencies for your package. Take a look at the new move.toml file. You should see the package information and an Aptos framework dependency. The Aptos framework dependency points to this GitHub repo main branch. Okay, let's take a look at that. Move.toml. I see there's the Aptos framework dependency over here. Very cool. Oh, and it even has the message board address defined here as the underscore. And if you remember, when the address here is defined is set to an underscore, that means that we will define what account will be the publisher when we run the publish command. Why sources directory? The sources directory holds a collection of .move modules files, and later when we want to compile the package using the CLI, the compiler will look for that sources directory and its move.toml file. I see. So it's important to put all of your move files inside of the sources folder because that's where the CLI will look. What is the test directory? The test directory holds .move files that are used to test the files in our sources directory. Cool. So, yeah, you can create separate move files to define your test, but also you can just define your test inside of the same file of your move module, just for convenience sake. But if you want like a fully fleshed out, like a very long unit test defined, then it's probably best to create a separate test file inside of the test directory. All right, create a move module. An account is needed to publish a move module. Yes, when we installed the template, the tool created a new account for us and added it to the .env file. Ah, that's very cool. So usually when we used to do Aptos move init to get like that bare bone project structure, we had to run Aptos init separately to get set up our default account to do like testing and publishing. But it seems like Create Aptos DApp does this for you and just put those account information inside of the .env file. So let's go to .env, and there you go. You see my publisher account address and the private key. Now again, I can't emphasize this enough. I'm showing my private key here. I mean half of it, but still, never ever ever do this. This .env file does not get pushed to a public GitHub repository. This must stay private, right? Because once you let this private key known to the world, then yeah, good luck. You know, it's not good. It's not good news. So definitely make sure you don't push this to GitHub when you commit, and also make sure never show this file to anyone else. Okay, so you just created a new account on the Aptos Dev Network. Yay! You can see it by going to the Aptos Explorer DevNet Network view, pasting the address value from your .env file into the search field and clicking on the drop-down option. Now, I've done this in my previous video, so I won't do this here for time's sake. The boilerplate template comes with a pre-generated messageboard.move file, a relevant test file, and a move.toml file. Okay, let's see. So inside of the sources folder, there's the messageboard.move file. Cool. And there's the test for our messageboard module. As mentioned, our sources directory holds our .move module files. So let's create a new to-do list.move file. Oh, so we're not using this messageboard module. We're creating our new one. Love it. All right, so to-do list.move file. Let's create one inside of the sources directory. Nice. Oh, by the way, this guide actually doesn't mention this, but right now in my VS Code, I have the move extension set up called Move on Aptos. So this is an extension created by team at Aptos Labs. Is the most up-to-date, highly maintained extension for Move on Aptos. So definitely install this for your VS Code so that you get all the syntax highlighting and the hints. All the good stuff. So it will just make your life easier as a developer. So trust me on this one, and install this and set this up. So like for example, if you go to the messageboard.move, you see all these syntax highlighting. making my code look pretty and it's giving these type hints on like, oh, this board object signer, by the way, it's a signer type. It gives all these amazing information for you as a developer. So definitely, this is a must. It's an essential extension if you're writing Move code. So just to really clarify how to do this, go to the Extensions tab, search Move on Aptos. You will find this one, created by Aptos Labs. I have it on installed right now, but there will be an install button. Click the install button, and that's all you need to do. I mean, beyond that, you can add extra configurations, but you don't really need to do that in the beginning. Later down the road, if you feel like, hey, I want to configure a bit more, just check out our configuration docs, and you'll find all the instructions on how to customize the extension to your liking. Okay, so extension installed. Let's continue on with the guide. Okay, so we created the to-do list.move file, and it says to add the following to that file. An empty module. Okay, so here we see that we have an empty module, right? So to define your smart contract on Aptos Move, all you need to do is write the module, put in your publisher's address. And in this case, this to-do list _ adder should be defined inside of the move.toml file. So right now it's called message board adder. I assume, If you come to our guide here, it says open the .move toml file, add the following code to the move file. So we're gonna add this to-do list.adder into the addresses field. So we just set that, created that publisher address defined inside of our move.toml file. So that's what we are putting over here. And this is basically saying, hey, whenever I publish this to-do list module, I'm gonna publish it with the to-do list _ adder account. And this is because all Move modules have to be associated with an account at compile time. That's just how things work on the Aptos world. So this is to-do list _ adder, : and the name of the module, to-do list. And we put our curly bracket, and all of our Move module code will go inside of this curly bracket. Cool. All right, we have a note here. A Move module is stored under an address. Oh, yes, it's mentioning that. So when it's published, anyone can access it using that address. Yes, so Move modules by itself doesn't have a unique address. Like if you're coming from the Ethereum world, like Solidity contracts. So to find a published Move module, you have to go to that publisher's account information page. And you'll see all of the modules published by that account. And that's where you will find the published module. So you see that the module name is consisted of the account address, : and the name of the module. In our module, the account address is to-do list adder, defined inside of the move.toml file, and the module name is to-do list. Cool. What is the underscore in the move.toml file? I also mentioned this already, but let's read it. The underscore is a placeholder for the account address. When we run the Move compiler, the compiler will replace it with the actual account address. Create Aptos DApp comes with pre-made scripts to easily run Move commands like compile, test, and publish. Oh, interesting. I guess we'll find out what those commands look like. Open each of the files in the scripts /move directory and update the message board adder variable to be to-do list adder. Okay. I see. So inside of the named addresses, we should probably copy that. I see. So later when we run each of the Move commands, it will run these scripts and replace the underscore with the actual account address that assigned to the to-do list adder variable. All right. So let's go to scripts /move. I see there are compile, publish, test, and upgrade. And inside of the named addresses property, we update that to to-do list _ adder instead of message board adder, the default account that comes with the boilerplate template. Okay, compile is done. Let's publish. Let's see. There we go. Message board. Changed. Anything else? Cool. That's done. Tests. All right. Change that to to-do list adder again. Upgrade. Change it to to-do list adder. Beautiful. That should do it. All right, cool. Let's move on. Our contract logic. Before jumping into writing code, let's first understand what we want our smart contract program to do. For ease of understanding, we'll keep the logic pretty simple. An account creates a new list. An account creates a new task on their list. Whenever someone creates a new task, emit a task created event. Let an account mark their task as completed. Okay, fairly simple. Creating an event is not mandatory yet useful if DApp users want to monitor data such as how many people created a new task using the Aptos indexer. Very cool. So I'm thinking this guide will probably cover using the Aptos indexer as well. Very cool. We can start with defining a to-do list struct that holds the tasks array, so a list of tasks that's created, new task event, a task counter that counts the number of created tasks. We can use that to differentiate between the tasks. Okay. And also create a task struct that holds the task ID derived from the to-do list task counter. I see. So the task counter will be the ID, address the account address, who created that task, content of the task, and whether it's completed or not, a Boolean value. On the to-do list.move file, update the content in the module with these two structs. Okay. Let's do it. Paste that in. Make sure I indent that. All right, cool. So here we're defining these two structs, the to-do list and task. And the to-do list is a resource because it has the key ability. It has these three properties: tasks, which is a table of UN64 to the task struct, and we have the task event and the task counter. And the task struct has the store ability, so that's why this struct can be stored inside of this to-do list struct. And it can be dropped and it can be copied. And it has the ID, address, who created the task, the content of the task, and the Boolean value. We're getting these red strings because we haven't imported in these things yet, but I assume the guide will let us know how to do that. What did we just add? A to-do list, a struct that has the key and store abilities. Key ability allows struct to be used as a storage identifier. In other words, key is an ability to be stored at the top level and act as a storage. We need it here to have to-do list be a resource stored in our user account. So that's why the to-do list has the key ability. When a struct has the key ability, it turns this struct into a resource. Resource is stored under the account. Therefore, it exists only when assigned to an account and can be accessed through this account only. So it becomes unique and is owned by the account. And it's stored in a global storage. So that's what a resource is. Task, a struct that has the store drop copy ability. Store is used because task needs store as is stored inside another struct, right? Copy because value can be copied, and drop because value can be dropped by the end of scope, right? Because once we finish the task, this is probably going to drop it or something. Let's see. Let's try to compile what we have now. Run npm run move : compile. Okay, let's copy this command over and run it. So this is where these scripts is coming in handy. And it's probably defined inside of a package.json file. Yep, you see, inside of the package.json file, we have these scripts defined. And when we do npm run move : test or compile, it's running the compile file defined inside of the scripts/move directory. So usually, you would have to do something like aptos move compile -- named address, and then like pass in the name. I guess it's a bit of a hassle to do it multiple times when you're building your application. So by having this script, we just do npm run move : compile, and it will run the compilation process. Now, I knew this was going to fail. So you see that move compilation failed, unresolved addresses found. Named address, message board, adder, and package message board. Okay. Huh, that's not the error that I expected, to be honest. Let's see. Seeing errors. Yes, I am seeing an error. We have some errors on unbound type. Right, so that's the error that I expected, but this is giving me an unresolved addresses found error. Let me try going to move.toml and removing this message board adder and rerun the command. There we go. Now we're getting the error that I was expecting. The message. You know what? Here's what I'm going to do. Because we're not going to be using this message board.move file and the test, I'm just going to delete them. Because we're creating a new app here, right? And those just come with the boilerplate template. So deleted the two move files for the message board application. But now let's run the compile again. And there we go. Now we're seeing just the unbound error that we were expecting. Okay, let's go back to the guide. Seeing errors. Yes, I'm seeing the unbound type error. This is happening because we used some types but never imported them, and the compiler doesn't know where to get them from. So the way Move programming language works is that you have all these predefined types and functions and modules that are already defined, right? And you need to import them if you want to use them. And this is how most programming languages work as well. So here, on the top of the module, import those types by adding these 3 lines of code. That will tell the compiler where it can get those types from. Nice. Okay, so let's go to our to-do list.move file and go to the top of the module and import these 3 stuff. So the way import works is you do use and then you import the module or a function or a type that you want to use inside of your Move module. So we're importing in the event module from the Aptos framework, the string type from the standard library, and the table struct from the Aptos standard library. Very cool. And now all the red lines are gone. Love to see it. All right, so run the npm run move compile command again. If all goes well, we should see a response resembling where the resulting account address is your default profile account address. Cool, cool, cool. All right, let's go back and open up our terminal. All right, let's do clear so I don't see that ugly error again. npm run move compile. All right, it's compiling. Boom, there we go. We got the result to be the account address that's inside of our .env file, : to-do list, just as we expected. Beautiful. Yeah, so here in this guide, it's also, it didn't delete the message board, but you know what? Doesn't matter. We're not going to be using that anyways. All right, so we compiled our move module. It's not finished yet, but we compiled it. All right, so here now it's saying we can also delete the message board.move file as we won't be using it and remove the message board adder from the move.toml file. It would have been nice if the guy told me to do that earlier. So let me take a note of that and make that change and improve this guide. Okay, next step. Let's make sure everything is still working by running the npm run move compile command again. I'm not going to do that because I already deleted the message board stuff. We also have a new move/build directory created by the compiler that holds our compiled modules, build information, and sources directory. Okay, let's find it. Where is it? Build directory. Okay, this has the message board in here. I thought I deleted the message board. Let's see. To-do list. Okay, so it is a to-do list, but for some reason this is saying message board. My assumption is that it's because the package name over here is called message board. So we should probably change this to-do list. And let's try compile again and see if that recreates the directory. All right, and if you go to build, there we go. Now we have the to-do list directory properly created. All right, now let's create our first function, create list. First thing an account can and should do with our contract is to create a new list. Creating a list is essentially submitting a transaction, and so we need to know the signer who signed and submitted the transaction. Add a create list function that accepts a signer. All right, let's copy this over and let's put it over here. Okay, let's understand the components of this function. Entry. An entry function is a function that can be called via transactions. Simply put, whenever you want to submit a transaction to the chain, you should call an entry function. Right. So this create list function is a function that a user will be interacting with. So an external account needs to call this function. So in those cases, you need to make it a public entry function. It's not good enough to just make it a public function. A public function is still callable from other move modules, but it's not accessible from like the end user external account. So making an entry is very important. And then this create list function is taking in one parameter, which has the reference signer type. The signer argument is injected by the move VM as the address who signed that transaction. Right, so if you need to access the sender of the transaction, you just provide the signer into the argument. Our code has a to-do list resource. Resource is stored under the account. Therefore, it exists only when assigned to an account and can be accessed only through the account, right? That means to create the to-do list resource, we need to assign it to an account that only this account can have access to. Right, the create list function can handle that to-do list resource creation. I see. So probably inside this create list function, we're going to create that to-do list resource for the account that's calling this function. Add the following to the create list function. All right, let's copy that over and let's replace this empty function with this one. Ooh, okay. There we go. This function takes in a signer, yes, creates a new to-do list resource and uses move_to to have the resource stored in the provided signer account. Okay, let's take a look at what that means. So we have a create list function here. First thing, we are creating a new to-do list struct and setting these three values. So remember, the to-do list struct has the task, set task event, and task counter. And we're creating an empty table by doing table : new. And remember, we imported in the table struct over here. The set task event is, we're doing that by doing account : new event handle. And this has the task struct and passing in the account, which is the sender of this transaction. And the task counter is set to 0. And we move the to-do list resource under the signer account. So we call the move_to, which publishes T under signer.address. So remember, resources have to live under an account. That's what's happening here. We're moving the task holder struct to the account, the sender of this create list function. Okay, so we covered create list. Now let's create task inside that list. As mentioned before, our contract has a create task function that lets an account create a new task. Creating a task is also essentially submitting a transaction, and so we need to know the signer who signed and submitted the transaction. Another element we want to accept in our function is the task content. And again, this is the user submitting the transaction, so it should be a public function. Add a create task function that accepts a signer and task content and the function logic. Okay, let me just copy this over, paste that in, and we'll see what's happening later on. All right, that looks wrong. Okay, indent, there we go. Looks good now. Since we now use two new modules, signer and table, you can see it being used in signer : and table : we need to import these modules. At the top of the file, add those two new statements. Okay, let me copy that over. And let's come up here and import these two imports. This one we already have, need to modify it. Right, because we're importing the table over here. So is the guy telling me to remove that? Okay, back to the code. What is happening here? First, we want to get the signer address, so we get this account's to-do list resource. Then we retrieve the to-do list resource with the signer address. With that, we have access to the to-do list property. Let's take a look at the code here. Right, so the argument that we take in is a signer type, but we need to know the account address to access the resource stored under that account. So we're using the function stored inside of the signer module called address of, and we're passing the signer here, and this returns the account address. Then we use this inside of borrow global mute, where we are retrieving a mutable reference to the to-do list struct by passing in the signer's address. So now we have a mutable reference to the to-do list resource stored under the sender's account. Cool. We can now increment the task counter property and create a new task with the signer address, counter, and the provided content. We push it to the to-do list tasks table that holds all of our tasks, along with the new counter, which is the table key, and the newly created task. Okay, let's take a look at that real quick. We're incrementing the task counter by accessing the to-do list, a struct, the reference to it, accessing the task counter field, and then we're just adding 1 to that. Now we can do this because this is a mutable reference. Now this is very important inside of Aptos Move. If you were to have done borrow global, just like that, you would have gotten an immutable reference to the to-do list struct. That means you can't do stuff like +1. You can't change the value. It's immutable. You can only read the value. But since we are changing and updating the value stored inside of the to-do list resource, we are getting a mutable reference. That's why we can just do add 1 here. Okay, so we add 1 and we store that in the counter variable. Then we are creating a new task. So again, to define a new struct, you just do the name of the struct and open a curly bracket, and you paste in all the fields. I'm just going to indent that in to make that look prettier. Task ID should be the counter, remember, because that's what we said we're going to do in our design doc. The address is the signer address. Content is the content string that we pass in as argument, and completed should be set to false because obviously it's a newly created task. Okay, so the task struct is now stored inside of the new task variable. And now we are adding the new task into the tasks table. So this table module that we imported in has this upsert function, and you can use this to update the key value pairs stored inside of the table. A table is basically like a dictionary. It's just a series of key value pairs. A key is associated with a value, and there's a lot of it inside this table. So for self, we are passing in the tasks table that is stored inside of the to-do list struct. So that's really this, it's this one right here. And for key, we're passing the counter, which is the task ID, and we're passing in the newly created task struct into the table, because the table holds a key value pair of the number and the task struct. So Aptos Move is really great because you can work with complex data types like this. You can create a table and you can store structs inside of that table. It's really great. Like usually you don't have this much flexibility when it comes to data storage on chain, but you can do a lot of stuff with the flexibility that Aptos Move provides for you. After we update the table, we're going to set the task counter to be the incremented counter. So we access the task counter inside of to-do list struct, and we assign that to the updated counter that we have stored over here. And then we're emitting an event. Okay, let's go back to the guide. Okay, so then we assign the global task counter to be the new incremented counter. Finally, we emit the task created event that holds the new task data. Emit event is an Aptos framework function that accepts a reference to the event handle and a message. In our case, we're passing the function a reference using the ampersand sign to the account's to-do list resource set task event property as the first argument, and the second message argument, which is the new task we just created. Remember, we have a set task event property in our to-do list struct. Okay, let's take a look at the code because I don't really understand what that's saying. And the emit event function takes in a handle ref and the message. So for handle ref, we're getting a mutable reference by doing borrow global mute of the to-do list of the signer's address, and we're accessing the set task event. I see. So the set task event is the handle ref that we have created over here. I'm sorry, not here. Over here inside of the to-do list struct. And then for the message, we are passing in a new task, which is the task struct over here. So it seems like to emit an event, you need to create this handle ref and store it inside of a struct. That's this by doing event : event handle and the message type that we want to emit, which is the task struct here. And we pass in the message, which is the newly created task struct. Okay, very cool. All right, let's move on. Complete task function. I believe this is the last function that we need to define. Another function we want our contract to hold is the option to mark a task as completed. Add a complete task function that accepts a signer and a task ID. Okay, let me copy this over first. Indent it in. Cool. Let's understand the code. As before, in our create list function, we retrieve the to-do list struct by the signer address so we can have access to the tasks table that holds all the account tasks. Right, that's what we're doing signer address of. Then we look for the task with the provided task ID on the to-do list.tasks table. So we are getting that specific task that we want to complete by passing in the task ID as the argument and using that to get that exact task. Finally, we update that task completed property to be true. All right, let me just do a quick deep dive with this to see how it actually works. So a couple things that the guy didn't explain here. One is that first, it's an entry function because it's a function that the end user have to call. And this has this thing called acquire to-do list. And we also had this for create task and also, not for create list, but for create task and create complete task, acquiring to-do list. What does that mean? So in Aptos Move, if you want to retrieve a struct or a resource, you need to acquire them inside for your function. So for complete task, we are retrieving the to-do list struct by doing borrow global mute. So if I want to do this, I need to specifically say that, hey, this function needs to acquire the to-do list struct. So that's what's happening over here. So TLDR, if you need to work with structs inside of a function, acquire them. Cool. Okay, so we got the signer address by doing signer address of, and then we are getting a mutable reference again to the to-do list struct from the signer address. And we are doing table : borrow mute function inside the table module. And what does this do? Acquire a mutable reference to the value which key maps to. Abort if there's no entry for key. Ah, I see. So this is how we get the mutable reference for the value associated with the key that we provide. So the self is probably going to be the table that we are going to look into, which is going to be the tasks table inside of the to-do list struct. As a reminder, that's this one right here. And we need to pass in the key, which is the task ID. So we get that from the argument. So that's what we do. And this is going to return the task record, a mutable reference to the task record. And this task record will be the task struct of that specific task, for that specific task ID. And this has this completed field, remember? So all we're doing is doing task record dot completed equals true. So we're updating that value from false to true. Nice. That's really cool. The way you access these tables and like this example is really showing you how you can work with structs and complex data types, nested fields, nested structs. And it's really straightforward how you can just gain access to them. And you can just update the values by doing a mutable reference to them. So I really think this is although it's a simple application, it's quite showing you a lot with this example. Okay, let's move on. Now try to compile the code. Run npm run move::compile. Now you see, as you can see, when we're building applications, you need to run these commands a lot of, like multiple times. And that's why having these helper functions defined for you is super helpful. You know, you really need to type in aptos move compile -- name addresses every single time. You just do npm run move::compile and it compiles it for you. So that's really nice that Create Aptos DApp does that. All right, let's run compile. Let's see if it works. And it fails. Let's see what happens. Okay, so first thing, alias previously defined here. I see. So interestingly enough, I don't know, does the guide mention this? No, it does not. Okay, so that needs to be updated in the guide, but it has a comment, funnily enough. But since we are importing in the table struct over here, the way we're doing this, the reason why we're doing this over here, like we're doing the curly bracket and self, and when we do self, this means that we are importing in this table module itself. Beginning, when we only had these two structs, we were only using the table, the table type, and not all of the functions that are inside of this table module. But if you look below inside of create list, we're using the table module and accessing this new function that is defined inside of that module. And this table module, if I go into the definition, is just like any other Aptos move module. And you have all these functions defined in there, like the new function that we just used. So if I want to access all these functions inside of this module, I need to import the module itself. That's why we're doing self here. But we're also importing in the table struct separately because, you know, I don't want to do table : table. I just want to keep it simple and just do table with with the capitalized T. So that's why we're doing that. So all I need to do is remove this line here and that should work. Okay, so that's done. What's the other error? Okay, so we have an error here, unbound module for account. Okay. Account. Am I not importing that in? Oh, it seems like I am not. Did the guide mention it somewhere? Account. Let's see. It seems like the guide doesn't mention that either. Okay. Oops. Yep, we're not importing in the account here. Where else? Yep, we're not importing in the use account here. Oh, it actually did. Okay. Oh, so I didn't read the guide to the end. So that was supposed to happen. Another unbound error to fix this, add a use statement to use the account module. Use Aptos framework : account. Okay, this guide is messing with me. All right, Aptos framework : account. Done. Okay, let's run compile again. Now it should work. Building to-do list. Boom, there we go. It compiled successfully. Beautiful. All right, what else is left? Add validations. As this code now compiles, we want to have some validations and checks before creating a new task or updating the task as completed so we can be sure our function works as expected. Okay, add a check to the create task function to make sure the signer account has a list. Right, because right now our create task function, if you look at them, has no validation. So anyone can call this. But the logic is, the account that's calling the create task function should have a list initialized already, because you need to initialize an empty table to store all of your tasks, right? Well, what if someone calls this create task function before calling create list function? Then they're going to get a nasty error, right? And we don't want that for our user. So that's why we're going to add some asserts here so that they're not able to call this function if they don't have a list initialized. So how do we do that? Okay, so we just need to add these these code over here. I'm going to copy that, paste that in at the top, and cool. Now let's see what's happening. So we're getting the address of the signer. Then we're saying assert. So the way you do assert is assert exclamation point, open parentheses, and then we are asserting that the to-do list for under the signer address exists. So there's this exist function in move that we use that returns true if a T is stored under address. So we're checking if this resource is stored under the account. And if it does, great, continue on. But if it doesn't, we're going to give this error code 1. That's what's happening. So now, accounts that doesn't have list initialized by calling create list won't be able to call this create task function. Cool. So add a check to the complete task function as well to make sure the signer has created a list, task exists, and task is not completed. Oh, so we're checking 3 things over here. And we are doing that by adding these code. All right, let's copy that. Complete task, go here, go to the top, and boom. All right, let's make sure everything is indented properly. And let me just put some, cool. So what are you doing here? We're getting the address. So by this time, you should be really familiar with this function here. You use this a lot when you need to use the account address. We're asserting that the to-do list exists. Same code as above. Cool, done. Next, we're getting a mutable reference to the to-do list of the sender, getting that. And we're asserting that the table contains this task with the task ID. Because remember, the complete task takes in the task ID argument. So this contains function inside of the table module returns true if, oh, there's a typo, returns true if self contains an entry for key. Cool. So it checks if that task exists. If it doesn't, it will give the error code 2. All right, done. What's next? We're gonna do table : borrow mute. So we're getting a mutable reference to the value, right? So we're passing in the task ID to get the task struct inside of that table. And then we're asserting that that completed Boolean field is set to false. Because if it's already completed, then why are we calling this function again, right? So if this is false, we give the error code 3. Nice. And if all of these asserts go through, we update the completed property to true and done. Huh, okay, so this probably shouldn't have been in there because it's already down here. So let me remove that. So yeah, this shouldn't exist here. Noting. Okay, we just added our first assert statement. If you notice, assert accepts 2 arguments. The first is what to check for, and the second is an error code. Instead of passing in an arbitrary number, a convention is to declare errors on the top of the module file and use these instead. On the top of the module file, under the use statements, and add those error declarations. So we take these, go to the top of the module. I'm going to put them under the imports. And there we go. So what's happening here? Interesting. Okay, so now we can update our asserts with these constants. So instead of putting 1, 2, 3, we can just use these constant names in place of those numbers. So you see how for the create task function, instead of doing 1, we're passing in e not initialized. So the convention is for these error constants, it should start with a capital E and then the name of the error message. So let's change that. So for 1, going to put e not initialized. And for on our complete task, we also have another error here, not initialized. Cool. And let's just copy this and do it. For error code 2, task doesn't exist. And for 3, task is already completed. Why are you calling this function? Beautiful. Okay, that's done. Wonderful. Love the person who wrote this. Let's stop for one moment and make sure our code compiles by running the npm run move compile command. Oh man, is this gonna error again just like last time? I don't know, this guide is full of surprises. So npm run move compile. Compiling. Yes, this time it worked right away. Beautiful. Okay, if you encounter errors, make sure you follow the steps above correctly. This time, I got it right. Okay. Write tests. Now that we have our smart contract logic ready. Oh, so that's it. That's the entire to-do list move module. Beautiful. We need to add some tests for it, right? Because you always want to test your move modules. First, delete the test end-to-end.move file in the test directory. I already did that, as we won't be using it. For simplicity, and because we don't have much code to test, we use one function to test the whole flow of the app, and we'll have it in the to-do list.move file. Aha! So remember I told you that you can either define your test in a separate test file under the test directory, or you can just write your test inside the same module, same move module. So that's what this guide is doing, because we only have one function. Very cool. The test steps are, we create a list, we create the task, and we update the task as completed. So we're basically calling those three functions that we defined there. Add the following code to the bottom of the to-do list.move file. Okay, let's copy this, go to the bottom of our contract, and paste that in. Cool. Note, test functions use the hashtag test annotation. I see. So I guess this is how the compiler knows that these are test functions and these are not production code. And when you run the test command, it will find these functions and run them. We need to use entry here because we are testing an entry function. Aha, okay. Interesting. So if I need to call entry functions instead of the test function, I need to make the test function also entry. Noted. Update the test function to be, wow, okay, a lot of asserts. Let's do this. Okay, let's replace this and paste that in. Cool. Our test annotation has changed and declares an account variable. Additionally, the function itself now accepts a signer argument. Yeah, it does. Now our test annotation has this admin equals at 0x123, and the function is taking in a signer. So what's up with that? Let's understand our test. Since our tests run outside an account scope, we need to create accounts to use in our tests. The test annotation gives us an option to declare those accounts. Ah, I see. So that's where you declare accounts that you're going to use for testing purposes. We use an admin account and set it to a random account address. So I guess you can just do at 0x whatever number and create a random fake testing account. The function accepts this signer and creates it by using a built-in function to create an account for test. Then we simply go through the flow by creating a list, a task, and updating the task to be completed, and assert the expected data behavior at each step, just like how you would write normal tests. Before running the test again, we need to use some new modules we are now employing in our code. Oh, okay. At the top of the file, add this to the use statement. Already have it, need to modify. Okay, so this is probably the similar case for the table one. So we import that in, but since we are importing in the string type already over here, let's just get rid of that. And now everything's good. I'm just going to remove these commands because, hey, I addressed these issues. Beautiful. Then run the test command. If all goes right, we should see a success message like this. Okay, so let's go back to our test and see what's happening. Okay, so we come down here, we have a public entry function called testFlow that takes in a signer called admin, and it's acquiring to-do list. And this has the test annotation with admin set to 0x123. So inside of move modules, you use this at sign to say that this is an account address. So that's how you set up the testing fake account for your test. So we take in that signer, and then we create an admin to-do list adder account for test. We do that by using the account module, calling the create account for test function, and we pass in the address of the signer, admin. Nice. And the reason why we're doing ampersand here is because the signer is not a reference. But usually for other functions, the signer was a reference. So that's why we have the ampersand here. All right, so now we have the account. We're going to initialize the contract by calling create list. Remember, we need to create an empty list first using the admin account. Boom, done. Then we need to create a task by the admin account. So we call the create task function. So we do that. It takes in the account signer and the content. So we're using the admin account, and for the content, we're passing in string : UTF-8 B new task. Now, inside of move modules, you can't just you can't just play around with string types because it's not supported. So you need to use the string module, use the UTF-8 function, and pass in bytes. And I know it looks complex, but trust me, once you get used to it, it will come in second nature. You just use the UTF-8 function inside of the string module, and you pass in the byte type, and all you need to do is create a string, just like normal strings, usually in other programming languages, and just put a B in front of it. And that will make it a byte value that UTF-8 function takes in. So right now this test has a new task. You know what, I'm just gonna make it fun, and I'm gonna change the task, and I'll change the task to create E2V guide video for Aptos devs. Cool. That's my task, and I'm working on that right now. Then we are using the event module, : counter. Okay, interesting. So it returns the current counter associated with the event handle. Oh, so events have a counter associated with them. And we're doing borrow global of the to-do list struct that's stored under the admin account. And we're getting the set task event handle. And so this is how you get the counter for your task event or your task. And we get that task count, and we assert that the task count is equal to 1 because we only created one task. And for to-do list, we're doing borrow global to-do list from, again, the admin account. So now we have an immutable reference to the to-do list struct, and we're doing to-do list dot task counter is equals 1. Right, because we have a separate task counter inside of our to-do list struct as well. Next up, we are doing table : borrow. What does this do? Acquire an immutable reference to the value which key maps to. Okay, so it's an immutable reference. Wasn't there a... What's the other? Oh, borrow mute is the mutable reference one. Okay, so this time we're getting an immutable reference to the value that's associated with this key, which is the task counter. Right, because all tasks, unique ID is the counter. Okay, so we get the task record, which is the task struct, and we access the 4 fields inside of that struct. Task ID should be 1, completed should be false because we haven't completed yet. A content should equal now this custom task that I created. Change that. And the address should be the admin address. Straightforward. Cool. So we created our task. Now let's complete the task. So we call the complete task function with the admin account, and the task ID should be 1 because the task that we created has the ID of 1. And this time we're doing borrow global of to-do list. So we're getting an immutable reference to the to-do list again, and we are getting an immutable reference to the value associated with the key value, which is the task struct. And now the asserts, it should be all the same, but this time the completed should be true and not false. And the task message should equal this. Beautiful. So this really shows you how you can write like end-to-end unit tests for your functions. You're basically calling the function, and then afterwards you're just doing asserts and making sure that you get the expected value. Beautiful. So I have the test defined. Now we run npm run move :test, right? Because we have the test script also defined inside of this template. Let's run it. Go to my terminal and run the test. Beautiful. So it says running move unit test, and you can see that it's calling the test flow function inside of the to-do list module deployed by this account, and we get that the test result, one test, one passed, and the result is success. Beautiful. Everything works. What's next? Let's add one more test to make sure our complete task function works as expected. Add another test function with this. All right, let me just copy that. And it's a separate test, so I should put it over here. Cool. This test confirms that an account can't use that function if they haven't created a list before. The test also uses a special annotation #expected_failure that, as the name suggests, expects to fail with an not initialized error code. So you can also write tests where you expect it to fail. That's nice. All right, so let's take a look at this test. So again, it has a test annotation to say that this is a test function. Admin is still set to 0x123. And now we have this expected failure annotation. And the abort code should be not initialized. And remember, we set this above as a constant. So, account cannot update task function takes in the admin and it's acquiring to-do list. And first thing is creating the admin testing account by doing account : complete create account for a test. And then we're right away calling the complete task function, but we don't have a task created or even a list created. So this should fail, right? And this should fail with the not initialized error because we don't have the list initialized yet. So let's run the command again by doing npm run move :test. And this time it should run both of those test functions. Nice. So it called both of these test functions and both of them passed. Beautiful. Okay. Well, this says Aptos move test, but that's probably a typo. You should run npm run move :test here. Now that everything works, we can compile the move module and publish the move package to chain so our React app and everyone else can interact with our smart contract. Nice. Okay, publish to-do list module to chain. Run compile. So we need to compile it again. So we do npm run move :compile. Okay, I'm getting a warning because I am not using string. Why did the guy tell me to do that then? I am using it inside of this test function. It might be because I need to say that it's test only. Give me 1 second. Yeah. So, I mean, this is a warning, so it really doesn't matter. But, if you really want to, be a perfectionist like me, the reason why this was giving this error was because the string module itself wasn't used in the actual module, but it was only used inside of the test functions. So by giving the annotation test only for the imports where we're importing in the string module itself. This tells the compiler that, hey, like this is only for the test function. So if you don't see it in the actual move code, don't worry about it. So to actually really make it pretty, I should probably just like do it like that. And if I do compile again, it should work. There we go. No warnings. Beautiful. Okay. Oh, it even the guide mentions it again. I always go ahead. I'm so sorry, but let's quickly go through them. We're getting some unused alias alias errors. This is because we added the string alias before, since we use it in our test, but we don't use this alias in our smart contract code. That's why we're getting this error. To fix it, we can add a use statement that would be used only in test, and we do that by adding the test only annotation. Okay, so just to be extra sure, let's run the test again after changing the code, and we just check that the compilation works as well. Cool, our test passes. Nice. After doing that, we need to run npm run move :publish, and this is a script that's going to publish my to-do list module. So let's go to our terminal again and do npm run move :publish. Okay, so that's compiling my contract again. So I guess we really don't need to run compile before running publish. So it should just work because it compiles as part of its process. Okay, so it's asking me, do you want to publish this package at object address at this? Interesting. So it seems like this is using the object publish method. So to give you some context on Aptos, usually back in the days, when you do Aptos move publish, it would publish the module just under the account. But now we have this object model introduced to Aptos move, and now you have a way to publish modules as an object. And it just makes things a lot better because the module itself now has a unique address that links to that module, and it's just a better way to publish move modules. So a lot of people are preferring this, and I think Create Aptos DApp publish script is also taking this approach. Okay, does the guide tell me something about this? Okay, I didn't get an error, but the guy is saying, oh no, we got an error. It complains about an account mismatch. Apparently, we compiled the package with a different account we try to publish. Oh, well, they told me to update this field, didn't they? I guess I jumped the gun here then again. But I did go into publish.js and I updated the address name to be to-do list _adder. If you remember, I changed, where is it? Yep, this field right here. This used to be the default address that came with the boilerplate template, but I changed that to the to-do list adder that we have defined inside of move.tom. So that's why it worked for me. The guide, I think, thought that I didn't update that yet. Cool, let's go back to our terminal and let's go through the publish. So it's asking me, do you want to publish this package at object address? Yes. Enter. Oh, it does give me the error. What? Interesting. Okay, let's go back to the guide. Open the publish.js file, update the address name variable value to be to-do list _adder. Did I not do that? Let's go to publish.js. Oh, there's another property called address name, not only named addresses. Okay, you got me this time, guide. All right, to do list underscore adder. And if I run it again, will it work this time? Yes. There we go. Do you want to submit a transaction for a range of this amount of octaves as gas? Yes. Submit it. There we go. So our transaction is submitted and our code was successfully deployed to object address of this address right here. Beautiful. So now we have published our module. You can now head to the Aptos Explorer, link and view the transaction details. You can also see the module published on chain by looking for the object address. Check out your .env file and see the byte module address variable. It is set to the object address of the published module. Oh, that's really nice. So it does that for you, I guess, huh? So if I go to the .env file, and hey, there we go. Our module address is 0x1efa, and it's the same address as the console shows me. Beautiful. All right, let's first go to this link here and take a look at our transaction. Okay, that is on mainnet. Change that to devnet because all that happened on devnet. So make sure your network is configured properly. And yeah, so our sender is the B2DE account. That's the account that our Create Aptos DApp has set for me. And it's calling the object code deploy and publish function. So that's what we did to publish our module as an object, getting all these bunch of stuff. If I look at the event, yep, it's publishing the package. The object address is 0x1efa. Cool stuff. So let's go to this object address on our Aptos Explorer. Object, there we go. So we are now at this object page, and if I go to the module section, there's my published to-do list module. And you know, if you go to the code, you can see the actual code that I've worked with. You can turn this off, by the way, if you don't want to share your code with the world, and if you're shy. But by default, it does this. And you can even interact with your to-do list module by going to Run tab. And you can call create list, create task, and complete task, and see for yourself what it looks like to interact with your application from like a web page. I think that's it for this first section of the Build End-to-End DApp guide. The next guide up is to set up my front end. Cool. All right. Wow. That was a journey. That was definitely the longest guide that I've done so far at Aptos. But it was an interesting one. You know, we covered a lot of stuff. You know, we wrote the move module ourselves instead of just copying and pasting. We dived into the code to see what's actually happening. We got a glimpse of how Aptos Move works. I know this guide doesn't really specifically talk about the language itself, but we got a glimpse into how Aptos Move works here. We used the Create Aptos DApp tool to initialize, to bootstrap a boilerplate template that has all these scripts defined for you, and it really made my development process more streamlined. So that was really cool to see. And now we have a working to-do list move module published on .NET. So that's the first step of this end-to-end DApp mini-series. Next up, we're going to be covering setting up a front end for this move module, right? A front end meaning a web page that your end user will be interacting with. And they'll be clicking buttons to sign transactions and send transactions and call the functions that we have created just now. So super excited for that. And that'll be coming up in the next video. That was super fun. Let me know if you ran into the same issues that I did, or whether you made the same mistake that I did, kind of jumping the gun without reading the rest of the guide and panicking and thinking that you did something wrong. Let us know in the comments if you did that yourself as well. There were some things that the guide needed some improvements on. So there were some typos and So I noted all that down. I'm gonna go back and improve them. So by the time, hopefully, that you watch this video or you try out this guide, it's all updated and it's all working smoothly and beautiful. That being said, thank you so much for watching this long video. I'm super proud of you for getting through the end of this video and publishing your to-do list application. Next up, let's write a front end for this and build our full stack application. I'll see you in the next one. Bye.